Hi there, welcome back to the channel. Welcome to the start of a brand new restoration project. This is the Braun TS2 from 1956 and it is 68 years old and looking really good for it. In this video I go through the usual procedure, and there was one particular thing that I wanted to try here today, and that was to try out my Selenium rectifier replacement board that has a MOSFET and a 10-turn trim pot on there, which allows you to finely adjust the output voltage, the B+. I wanted to try it out because when I did try it out last time, it was on a test circuit. This is the first actual radio that I'm going to fit it into, and I was really curious to figure out if it worked well. I won't give you a spoiler. If you want to find out, you're going to have to stick around. The other challenge that this presented was the dial glass, which had to be replaced. And this is a Braun. So I've done this before. I did it on a Braun Atelier 1 where I literally redesigned or redrew the entire faceplate and had it redone. And it looks like this one's going to have to go through the same procedure. So quite a bit gets done here. We get to the end, and this is what she looks like. So if you enjoy this sort of thing, I invite you to stick around and enjoy the video. And here she is, the blonde beauty. Can you imagine walking into a store in 1955 and seeing this thing on a shelf, surrounded by the more traditional radios of the time, you know, the dark wood, the rounded corners, the gold stripes, you name it. This would have shocked the hell out of you. Now, you'd either love it or you'd hate it, depending on what your tastes were. But whatever that reaction was, it certainly would have got your attention. Now, as far as the functions are concerned, this was pretty normal. You've got the off switch, the phono input, long wave. That FARU, I think, is the ferrite antenna. And then you got the medium wave, the short wave, and the FM button as well. FM being the most important because that's the one that, for me, is really useful. And this is where the problems start. We've got problems with the bubbling behind the glass. I think the decal they had on there is peeling off. So I believe this whole front panel is going to have to be redrawn and reprinted on here. Yeah, well, the buttons are all fine. They just need some cleaning, but that whole faceplate, I believe, is going to have to be redone. The glass is in perfect condition. I think it's just the decal. And I found someone who does UV printing, and I think this will be a good opportunity for me to try that. By the way, my wife just heard me say that. I had to promise that I will not get a UV printer. Damn. And the grill cloth is going to have to be completely replaced because not only is it dirty, which I could handle, but it is torn. We'll look around and see what we can find. The actual wood is in perfect condition. If you see the sides there, there's no cracks, no chips. The top is perfect. I will be sanding it down and refinishing it, but I do want to keep that natural yellow look. I really like it. So I'm going to make sure that that color remains the same. Well, let's have a look at the back. It looks pretty much immaculate. This thing is almost perfect. A few stains here and there, but we've got the usual, the antenna inputs, the phono input, it's phono and tape. We've got the tube lineup, external speaker connection. Then, of course, we've got the mains selector and the mains cable and plug. Pretty short, but that's what we've got. Well, that doesn't look too bad at all. A little bit of dust, and there is a really strong smell of nicotine coming out of here, or tar. So this was obviously in a smoking household for many years. It's sort of a yellow mark or yellow tint on all the metal. It's going to be nice to clean off. But let's have a closer look. We've got those mid-range speakers on the side there. This rather massive main speaker and another speaker over there. That all corresponds to what we see in the schematic. So that's all fine and good, and they seem to be in good condition. We seem to have the usual lineup of tubes. There's the FM block with ECC85. What is this? This is an EF89, so it's an IF amplifier. It'll be a, where is the other one? What is this one? ECH81. Okay, so we're still within the normal tube lineup that we're accustomed to on these German sets from that era. And here we've got, what is this guy? Another EF89. This one's got a slightly different lineup. It's got two EF89s. What it's got, if it's got a dedicated IF amplifier. Is that an EABC80? Yeah, that's the detector. This is a triple diode triode, I think it is. It's the detector and the preamp. And here, very loosely, we've got an EL84. I think this is just loose from having been shaken around. So that's all normal so far. There's our transformer. We've got the voltage selection here, and there is a 240 volt. That's good. Normally these only have up to 220. This has got 240. It's got a fuse on here. This resistor has been changed. That's probably that first resistor between B1 plus and B2 plus. Okay, so somebody's been in here, at least on the top. There's our output transformer with this cap. This cap will be the one that's probably in the mid-range speaker or the tweeter speaker circuit. Oh, this has come loose. Okay, so one of these isn't getting a signal anymore because I think it desoldered from there. Okay, I'm going to have to take that out anyway, so I'll have to check. The filter caps, which will need to be changed. That's an electrolytic, that'll be changed as well. And I see some, oh, okay. Let's have a look at this. One of our coils here is broken, it's open. So we'll have to sort that out or we'll get no AM. And what about the dial cords? This thing's got a clutch mechanism, so if I am going to the front doing the tuning, and that's certainly working, and I can see the tuning condenser move. Now let me put it on FM and see if the other one moves. Yep, that's moving. Oh, that's really loose. This thing is new. This thing's been replaced, but it's very, very loose. But at least it's working. So everything seems to be, yeah, everything seems to be pretty good. Now there's something here that I've noticed. Apparently this antenna is rotatable because there's a wire going on there. Let's see if I can, oh, there we are. There's a knob on the front and you can rotate the ferrite antenna. A very small antenna. It's a little bit strange, but it's working. It rotates 360 degrees. It's working. So it's time to get this thing out of the chassis, and usually it's just 4 screws at the bottom. I will be desoldering the wires going to the speaker. Speakers are going to stay in the cabinet for now. So yeah, let me get this out of here so we can see what we're facing. I want to see that dial glass at the front there, and I want to see what's on the underside. She's on the operating table, ready to be looked at, probed, desoldered, fixed, corrected, whatever needs doing. But my first impression is, damn, there's a lot of space. And just like the case with the SK25, there are not that many paper caps on here. A lot of these are ceramics already. Everything's got a yellow hue to it. So this is tar from some smoker's house. I see one there that definitely needs changing. A few electrolytics. Some of these capacitors are the dog bone types, which tend to hold out quite well. But as I said, look at the space. Space for everything. There's no problem here. Getting into some of these components to desolder is going to be a breeze. I'm always a little wary about saying things like that because it sometimes turns out to be quite complicated. Somebody's been in here. That little blue guy doesn't belong. And one of these bolts has come loose. How the hell did that happen? That looks like more than nicotine. Something's spilt on here. But I'll turn around so we can look at the top side a little bit more closely. Again, the nicotine and dust makes for quite a paste. There's that resistor that I said's been changed. Yeah, that looks pretty straightforward. It looks pretty good actually. Other than the color, but we can clean that quite easily. Now I'm going to take out the knobs and remove the faceplate because I want to look at the back of that thing. Look what these buggers did here. Instead of using screws and a plate and a bit of metal to hold the faceplate in, they simply used 2 rubber bands. Genius. Simple but effective. And here's the mess that we find behind the faceplate. The entire coating has come unglued from the glass itself, and you can see that various attempts have been made to repair it, but that hasn't worked too well. Someone's used a bit of paper there, I presume with glue on the other side to hold it down. Yeah, it's a bit of a mess, and there's another attempt over here. But that layer is just bubbled up. No hope for that. And we get our first look at the front. Everything looks pretty much in order. Looks pretty neat, very simple. And we get access to be able to clean some of this. I'm not too worried about that because my airbrush system with alcohol will do short work of that. That should come out pretty well. Something definitely spilt on there. And just to check that everything works, here's the antenna rotator. That's fine. This is the treble control. Again, that moves a bit sticky, but it works. The tuning, that flywheel makes tuning pretty easy, which is great. There's the bass control, also moving, but also pretty stiff, so those pots need cleaning. And the volume control, same story. All right, let me get you up to date here. I've done quite a bit. The power transformer has been tested using the non-power up method that I described before in the Back to Basics series. And just so you know, that would be Back to Basics episode 2 and 3, I think it is. So I show you how to test the power transformer without applying mains voltage. So that's passed the test. What I did in the meantime is I removed that very short mains cable and I put a slightly longer one here with earth. This has got the green earth wire connected to the chassis. I'm going to be replacing this because I didn't have a long enough one, but for now it's better than the other one. I've replaced the filter capacitors. So this thing has been removed, restuffed with two 47 microfarad at 450 volt caps. I have not changed or checked the Selenium rectifier yet because I want to see what sort of voltage I get on there before I do any of that. But I was just in the process of testing the output transformer. And again, that's the simple test that I do without having power on. And the way to do that is again described in the Back to Basics series. I think it's episode 4, where you take a signal generator and you feed it to the anode of where the tube would be. Can you hear that? Put the volume up, or put the level up. My signal generator is producing 10 volts peak to peak, and you can hear it on the speaker, which means that our output transformer is probably good. Okay, that's good news. So we know the power transformer seems to be okay. We know that the output transformer seems to be doing its job. We don't know how well yet because we haven't applied power yet. I've got the filter caps replaced. And what I'm going to do is I'm going to power this up to check if I'm getting B+ coming out of the Selenium rectifier, because that'll tell us that the voltages are getting through. Right, I've done a bit more checking. I haven't checked the full B+ line yet, but I want to test this thing to see if the amp is working. So I've got the speaker coming out of here into my workshop speaker. This is just from the back speaker outlet. I have my signal generator producing an audio tone, I think it's about 800 Hertz, coming into the phono input over here. I have the multimeter ready to measure the B+ coming out of the Selenium rectifier. This time it'll be different because the tubes, especially the power tube back here, will be drawing current. That's the one that draws the most current in the whole set. And I guess we move back and hope there's no bang. So that's phono over there. That voltage is going up because the current is not being drawn by the tube yet, or not much. Oh, volume. Oh, there it is. Brilliant. Can certainly hear that. Let me make this tone less irritating. 400 Hertz. It's a little bit more tolerable. Let's see, I've got my volume. My volume is working. The amplitude coming in is only 100 millivolts, so I can put it to maximum volume without blowing us up. The bass, that shouldn't have much effect because I just want to see if it's scratchy. The treble on this side, I'm doing the same. There's no noise on there, which is great. And what I'm seeing is 230 volts. Let me put the volume down. I want to remove the restriction on there because what I've got is I've got one 40-watt light bulb. So I'm going to give it another light bulb, which means I'm going to effectively have 100 watts of light bulb restriction in the dim bulb tester. That's gone up. Let me put another 100 watts. So now we've got very little restriction. 260 volts. 260 volts. That is with the old Selenium rectifier on there. If I bypass the limit, 263 volts. Okay, now the other tubes aren't in there, so the current draw is not at its final amount, but what we're getting is 262. I wonder if that's good or bad. Well, it's a little low because I've just looked at the schematic and it says 270, but it's not far off. Remember, what I've got here now is I've got this thing on the 240 volt main selector. I changed it to 240 because my mains is mostly 230 something here. It's seeing 230 coming in, so it should be a bit low, but I think the voltage drop across that Selenium rectifier is a little bit high. So I'm going to do that swap over, and I'll be using the latest MOSFET dropper versions of to replace the Selenium rectifier, and with Silicon Diodes with a MOSFET voltage dropper, so we can adjust it. We should be able to adjust it precisely to what we want there at the end when this thing is drawing all the current that it's going to draw, meaning all the tubes are in. Okay, progress. We've got ourselves a power supply working, and we've got the audio amplifier working. I've got a confession to make. I jumped ahead. I couldn't stand the look of this thing any longer. This dirty faceplate, or the dirty front, and the smell from the nicotine or tar was just nauseating. The front and the underside where I had to work on, it was driving me nuts. So I decided to give it a proper cleanup. And this thing was tough. This was a lot tougher than I'm used to. This was not simply the use of the airbrush with alcohol like I normally do, and it sort of runs off and everything's great with that brush, and then, you know, cleaned off with some of those pads. I had to resort to paint thinner, and that was, well, that brought another smell on its own. Paint thinners all over the front. On the underside, I had to get a little bit more creative. I did not want to use paint thinner on the components, so I cleaned it first with the alcohol, isopropyl alcohol, sprayed from the airbrush, and, you know, brushed with the little paintbrush, and then sprayed off again. And then on the actual chassis parts, I used the paint thinner. If you use paint thinner on the components, you're left with blank components. You won't see any lettering on them, which is not a good idea if you want to follow the circuit later. So the result of that work was that we've got something a little bit more civilized. A bit of touch-up paint was necessary here and there. That back plate just comes off. You can clean it properly. And then everything else, things like these dials, they come off. They got cleaned separately. The pots behind them were properly cleaned and lubricated. So yeah, it's looking a lot better, and it's working a lot better. The pots are smooth. I'm not sure that they're going to be scratchy still, but we'll find out later. And then I had to go back a step because this has sort of jumped over the completion of the power supply stage, as you probably remember. But let me show you the schematic, and you'll see what I mean. This is where I am right now. Everything that is painted green has been checked. And I won't go into the details of how I do this because I show that in one of the Back to Basics videos. I do suggest that if there are things you don't understand here, check out the Back to Basics series. And it starts from, you know, part 1 all the way to part 11, in which I cover systematically different parts of the restoration process. I show you how I do that. I even show you how I paint these things. So what this means is that everything that's painted in green has been checked and is correct. Things like the resistor values, the switches, the continuity to the respective points where the power supply, remember this is all coming from the power supply, is supposed to get to. So the power will be getting to where it's supposed to get to, right? This is all tested without the radio on at this stage, right? So where's this coming from? Well, it's coming from the power supply. And the power supply is this thing down here. Now, this is what I call the B1 plus. Comes out of the Selenium rectifier, it goes to the first filter capacitor, which is actually this capacitor here, not that one. That's the first one. They're identical, but this is where you would get your B+, and it says 270 volts. And then it goes through part of the output transformer through a resistor, and then it comes to the second capacitor, which is what I call the B2+. So B1+, B2+, all right? Now these two you can see I've changed. This is that can with 2 capacitors inside. So that's been replaced, and I paint that in red. And then other than that, as you can see, the only other component is this capacitor here, which is the cathode bypass capacitor for the output tube. I normally replace that as a matter of course, and I put a 47 microfarad 50 volt in there. Okay, so that was very simple. Now, what I wanted to do was I wanted to replace the Selenium rectifier. The problem is that if you simply put 4 diodes on here, which is really what this is, it's a bridge rectifier. You can build it with 4 Silicon Diodes, like 1N4007s. That's what I normally use. You can put those in. The problem is your B+ coming out here. It's being produced here. It's smoothed by that capacitor. So that's B1+. That is going to be higher than what you'd expect because the voltage drop across the Selenium rectifier is fairly high. I mean, it sort of loses some voltage because of the chemical composition that they used in those days, which was the selenium. The diode action worked, but at a cost of some voltage drop, which means that if you've got voltage drop across a component that current's flowing through, you get heat. And the more heat you get, the more this thing tends to deteriorate, which causes more voltage drop, more heat. You know where I'm going, right? At some point, this thing will fail and it'll stink like crazy. So I normally change this as a matter of course. In the past, I designed a little PC board which actually fit precisely into the spot where the most regular selenium rectifiers fit. So it was shaped and sized so that the holes that hold the original selenium rectifier would hold the PCB. And that had 4 diodes, but it had something else. It had a resistor, or a space for 3 resistors actually in parallel at this point here. So between the output of the diodes and the output of the selenium rectifier, if you know what I mean, so that you could drop some voltage across it. Now that wasn't a particularly elegant way, but it's what most people use, and it's what I used in dozens of restorations, okay? I wanted to get smart. I wanted to get fancy. So I decided to try a MOSFET circuit, and that MOSFET circuit has a trimmer pot, a 10-turn trimmer pot on there, which allows you to adjust the voltage drop across the MOSFET, which is now going to be the power component, the one that's going to dissipate that heat, or rather convert that voltage drop into heat and dissipate it. And in that way, you can actually adjust quite accurately the voltage that you're going to get over there. Now, I've done that, and I've got to tell you, I'm really chuffed. This thing was, I did a video on this very recently, and I only used a test circuit. So this time is the first time I'll be using it in an actual restoration. And I am stoked. This thing works beautifully. I'll show you next. See that? That is our new selenium rectifier with a MOSFET dropper. And the way it's done is I've got this thing, I'll take the top off in a second, but there's a little hole here in which I'll ultimately be able to adjust the voltage. A few holes there for convection cooling. So let me take this out and show you what it looks like. There we go. Now that's pretty similar to the previous version. I've got the 4 diodes on there. I'll actually put a link to this video above so you can look at how this board developed. I described the schematic and the workings of it. And what I've got is the 4 diodes, which replace the selenium rectifier. And then what's happened here is, instead of reducing on the B+ line on the high voltage, this thing drops on the low voltage. So this thing actually creates a negative voltage to ground. And there's our MOSFET, the trimmer, and I can adjust this to give me the voltage drop that I want. So the voltage we're interested in is actually between ground, chassis ground, and the B+ coming out over there. So what we're getting is we're getting a negative voltage relative to the ground at the negative of the selenium rectifier. Look at the video, it explains it all. Now, I'm going to switch this on and I'll be able to adjust there, and you'll see what happens to the voltage. Let me put a multimeter in view. All right, I've got the multimeter connected between ground, and now I'm going to measure the B+. That's going to the first cap. So let's switch it on. We'll let it settle. I've actually got the dim bulb limiter on a very strict limit because I was a little nervous when I connected all this up. I'll be removing that limit in a second. Remember, we're looking for 270 volts at this point, and it will be low for a while because, as I said, I've got the limit on. The 2 audio tubes are in, none of the others are in. I'm going to remove the restriction, so no dim bulb limiter. Let's see what we've got now. 279. Let it settle. And we want 270. So I'm going to use the trimmer here. Drop a few volts. This is a 10-turn pot, so we can get really, really accurate, which is not something we particularly need. But look at that. Go up a bit. Damn, that's perfect. 270 is what it's supposed to be. I'm going to have to adjust it again when I get all the other tubes in, but that's how we do it. Now we're getting a drop across that, across the MOSFET, and I want to see exactly how much of that is the drop. Now remember, I'm measuring the B plus at the moment. My negative, or the ground lead of the multimeter, is connected to ground, to chassis ground. So the output, the negative output of that bridge should be negative. How much negative? Minus 9.2 volts. That is how much the MOSFET is dropping. So you see what it's done is it's kept the output, the negative output of the bridge rectifier below zero. And so it's deducting it from the total, what would be the final B plus, which is over there. See that? Now, why is this not going to be stable? Well, it's not going to be stable because if the mains supply changes a bit, it'll also go up or down. But that voltage drop will remain more or less constant, which is what we want. Good. That 10 volts or 9 volts dropping across the MOSFET, I think this thing draws about 100 milliamps max, really max. I'm not even sure if it says so on the schematic. Actually, it doesn't, but the Selenium rectifier is this guy over here. It's a B250C100, so 250 volts, 100 milliamps. So if I take the max 100 milliamps, which is not the current draw, it's probably a hell of a lot less than that. 100 milliamps, 9 volts, that's 0.9 watts. Now the MOSFET has got part of the PCB is acting as a heatsink as well. The underside of the PCB is also acting as a heatsink. And I've not connected this to ground. This thing's floating here. This thing is hanging on one leg. These two holes on there would fit exactly where the Selenium rectifier was, but I'm only lifting it on one standoff, and then I've got this second standoff which is holding it in place, and I'm going to put the cover on. I think I better switch this off. There we go. Now this hole over here gives me access to the trim pot. This is nice and secure. It's actually fairly secure. It won't rotate and it won't drop. And I think it looks pretty good. Well, folks, I just got sick of seeing this, this dirt, and more importantly, I got tired of the smell. The smell of this thing is pretty obnoxious. And this is from an ex-smoker. So I decided to do something about it, and I cleaned up the entire chassis. Now this was pretty tough. Instead of using the usual stuff, I had to use a lot of paint thinner, and went through that a few times, and then finally just sprayed it up with the alcohol. So we've got ourselves a clean chassis, and I'm ready for the next challenge. And now for something completely different once again. And that is going to be the faceplate, which I have to completely do. This should be fun. See, the paint is peeling off completely. It's become discolored. But fortunately, I was still able to read all the text on here. And more importantly, I was able to measure where everything was relative to the corners. So you guessed it, it's time for Illustrator. I had to recreate this whole thing. Now, I've done this before with the other Braun, the Atelier 1, but it's rather detailed and not really easy, especially if you want to get it accurate. But let me show you what I've done. So this is how it goes. I started a new project on Affinity Designer, which is like an equivalent of Adobe Illustrator. And this is what we get. You've got to measure everything very accurately. You start off obviously with the size of the faceplate. The whole idea is going to be to print this on a transparent film, which is sticky on the one side. So you basically stick this on the back of the glass once you've stripped everything off the glass. So it's got to be very accurate. I'm talking 0.2, 0.3 millimeter accuracy. In fact, this thing goes to 0.1 millimeters. So we're talking about measuring and testing and checking again, all right? So I normally start from everything referenced to the top left corner. I do it across, and then I check everything referenced to the right top corner just to make sure that everything's correct. And the first thing is to get the right color for the base. Now this color is something that I came up with by comparing the original faceplate with a Pantone set of colors. And I think this is, what is it? Oh, I can't even remember. E7EFF6, okay, for anybody's interested. The first thing is to mark in where all the holes are going to be. In fact, these holes are on the actual glass itself. That's the volume control, that is the tuning over here, that is the treble, that's the bass, and that is the antenna tuner. And then we've also got some transparencies. In other words, the glass, you've got to be able to see through it. So anything that's white, when it's printed, it's just transparent. So there's a little window to show you the level of the treble. There's another one here that shows you the level of the bass. This is the magic eye window. This one here is the number that you see for the antenna tuner or the antenna rotator. So once you get that done, you move on to the next step, which is to get some of the text in place. That is the text over here. Now this is the text that relates to everything except the bands themselves, which are in the middle here. Now the thing about this is you've got to get the right font. And I figured that the closest font that I could find, and believe me, this is not the exact font they used, because I'm sure that the one I used didn't exist back then. I use Arial Rounded. Now, again, you've got to measure the height, make sure the height is right, make sure the space between characters is right, and that takes a few experiments and printouts and then comparing it. I printed this out and again on a transparency and just put it over the top, make sure that it's correct. This is as close as I could get it, and this is actually 50% black, so it's a gray. It's gray on this sort of bluish background. And again, you're going to measure the exact positions, both from the top and from the edge. So you've got to work with the coordinates, make sure you've got all this down here, which allows you to adjust it very, very finely. And once you've got that, oh, there's one more, there's the logo. Again, the logo, same story, get the right place, get the right shape. So this is how I go about it. And I do each stage, and then I sort of, I close the group and I lock it. And then I started with the easiest one, which is long wave. And this is tough. This is tough because you've got to get the right, you've got to get the right font. And the fonts I used here were Arial, just Arial. And again, the right size, the right height, and the right spacing between characters. A lot of comparisons with the original. Get all that in place. Make sure you've got these frequency markers in the right position relative to the edge. Everything's got to be very, very carefully measured, checked, and rechecked. The height between this line and the lines of text is very, very accurate. I mean, it might be off by tenths of a millimeter, but it's very, very accurate. This sort of thing is really for nerds. I've got to admit, I am one, and for me, this is therapy. Just sit down and just focus on nothing else for a few hours, and this is what I come up with. So long wave is done, and then I would hide it, and I'd start with the next easiest one, which happens to be shortwave. Up here, same story. The height's measured from the top, from the edge, everything else, all the measurements are in place, all the bands are in place. And then I went on to, what did I do next? I did FM. You can see I was avoiding the difficult one down here. Let me just hide the shortwave for now. Same with FM. Again, these rows have got to be very, very accurate. These little white squares are windows through which you see the dial. Remember, the dial, the pointer is going to be behind this, so you've got to be able to see it. So you've got to draw these windows in, which is effectively where nothing's going to be printed on the transparent sticker, okay? And after that, I did the medium wave, and that one was not fun. Let me hide the other text. This one was a nightmare. This was a real nightmare to get done. Some of the names on here, some of you may actually find there's a misspelling of something because some of the text had been ripped out. And I had to look at my Braun TS2 to see if I saw the same cities or the same sources of the transmission. But as you can see, this is the amazing thing that this radio or radios of this era with this kind of faceplate tell you about the importance of medium wave, middle, at that time. These are all the stations you would pick up at different times of the day, obviously. But I mean, look at it. You know, you go all the way from You got Sweden, you got France, BBC, Lisbon in two places, funnily enough. And this was all on medium wave. I mean, it really is mind-boggling, the number of channels. You had USSR over there, quite a few from France. There's Budapest, Moscow, Berlin. You had West Berlin and you had East Berlin. Where's East Berlin? There's East Berlin over here. It's somewhere else as well, the Vatican. Amazing, really amazing, the range of transmissions that you had in those days. And it was all on medium wave, which is why when you move back and you click them all on, you see that medium wave was the one that was given the most importance. Anyway, that is it. That's what I did. And then what I did is I printed this out in wireframe like this. And the reason I did that is because I wanted to try to print this on, I exported to PDF, and then I printed this on a transparent plastic, not the sticky type, just the normal plastic sheet. This was actually done on an A3 that didn't quite reach, because this is 52 centimeters and the A3 is 42, so it was done in two halves and then put together. And this allowed me to place this over the faceplate and check that the positions were right. You know, the positions of the text, the position of the windows, and then I could nudge it a little bit left or right, or in some cases the entire row had to be corrected upwards or downwards. But this wireframe version allows me to check for the accuracy of the print, because the final result is the one you've just seen, which is this one. This is the final result that I had printed, and I printed it again on self-stick plastic, transparency. I ordered 2 copies actually, because sticking this is not like vinyl where you put water down and you can slide it around, get the position right. This is a sticker. And when I printed it in reverse. So in a mirrored version, because I'm going to stick this on the back side of the glass itself, which means the glass will be at the front, the stick will be behind it, just as if it had been screen printed or silk screened on the back. And of course it protects it, but you have to do it in reverse. And again, this was printed in two halves. So I'm going to have to find a place to actually join the two. I don't think we'll see the join. I think the one actually comes all the way to here, and then this will be a little bit at the end. I don't think you'll actually see the joint, but we'll see. I might make the joint right down the middle there, because that'll have a knob there, and it'll probably be hidden. But I need to clean the original glass. I need to clean it as clean as possible. I need to scrape all the paint off now, which is going to feel a little bit sacrilegious, quite frankly. The sort of thing you always avoid. Now we're going to do it on purpose. But I'm happy that I've got this done. And just so you know, these files, both in PDF, high quality print version PDF, and in the, what is this? This is the Affinity Designer, which is, I can't remember what the file extension is. I'll send this to whoever wants it, okay? I'll send it both in the finished version, in the finished format, PDF, and also in the Affinity Designer software file. So if you want to play with it, make your own, it's up to you. Just email me and I'll send it to you. Let me go clean that rather messed up faceplate so we can stick this on and see if we can see what the result is, because I've always got the final option of actually printing this with UV printer. That was my original plan, but somebody suggested I do this, and I'm going to try this first. Well, folks, the plan didn't work. I cleaned it all up, scraped it all up, which was kind of strange, trying to do the thing that you always try to avoid, but the glass is perfectly clean, so that wasn't an issue. I then stuck one copy of this on the back, and that's where the problem came in. It was still almost completely transparent. I should have expected that. Even the light gray or that blue was transparent, so that didn't work. This needs a white backing, and of course I can't do a white backing because I want those things to be see-through. The Magic Eye window, the treble level window, and all those little white rectangles there need to be transparent. So if I had to use a white vinyl or something, I'd have to cut each one of them individually, which is a hell of a pain. So I'm going to plan B. I'm going to try UV printing, and I'm going there this afternoon, see if they can do it. I'm not sure whether they'll do it on the spot, and I sure hope that works. Well, this is as much as I can do today because the faceplate can't be done on the spot. They can do it exactly the way I described it. It'll be printed in a UV printer. There'll be a backing color on everything except the little windows. So I think it'll come out all right, but I'll only be able to do that next week. So for the meantime, I've got a rather steampunk type radio with a transparent dial glass. I decided to put it on here because it's safer than floating around. Also, they suggested I replace the actual glass with acrylic, 4mm acrylic, because they say that printing on glass itself, the UV paint will end up probably chipping off. So that's where I'm at, and that's where I'm going to leave you for now, because I've got quite a bit to do next. And in the next video, I'll probably be completing the audio. I want to look at some of the tone shaping circuitry, check that that is all fine. Yeah, and at least, what have I done? I've got the cleaning done, I've got the power supply checked, I've got part of the audio checked, and I've got my MOSFET dropper in there, which is something I really was looking forward to testing. And this is the first time that I'm using it on one of my restorations. And I'm really, really chuffed with that. So this is where I'm going to leave you, and I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. So once again, thanks for watching. Bye for now, and stay safe.